Well, hello, good morning. Thanks for joining me for another sprinkler talk. If you remember, we've started to have this kind of reboot in 2021. So last week was the first episode of the 2021 series, and now we're back for the second presentation today. So this is episode number 35, and today we're going to be looking at town main fed water supplies for automatic fire sprinkler systems, and in particular looking at the problems or the benefits of town main solutions, and I guess the problems town main water supplies as well. And then after that, I'll kind of be introducing you to a solution, which is one of the products from Project Fire. As always, with Sprinkler Talk, this is designed to be an educational platform first and foremost. So, this isn't a big sales pitch for our product. They will be talking about towns mains, looking at the problems, then I'll show you a possible solution, which is our product. But yeah, if you want to know more details, then obviously get in touch with us. But like I say, it's not going to be a big sales pitch presentation. Maybe I didn't introduce myself last week. Maybe I forgot to do that. But yeah, my name's Andy Fisher. I work for Project Fire Products Limited. We're based in Staffordshire. We've been in the sprinkler industry for since 1976. And I've been in the industry myself. I think I'm on 9 years now in the industry. Okay, so let's get a move on then with the presentation itself. So yeah, thanks for joining in. Again, if you've got any questions, you can pop them into the chat function. Okay, so first of all, town main water supplies. First of all, I want to kind of sell the benefits of town main water supplies for sprinkler systems. So first of all, they're the cheapest. They require the least amount of equipment. Okay, so there's no fire pumps to buy. There's no water storage tanks to buy. There's no sort of switch gear, generators, no fuel to buy. You don't have to worry so much about the thing of the pump room. So there's lots of kind of cost savings for using town main water supplies. They take up the least amount of space. Again, the main thing that takes up space for traditional pump and tank solutions is the water storage tank. Okay, with a town main supply, then we don't need that. But again, we're going to save ourselves a lot of space. They're also the easiest to maintain. Similar reasons, the less equipment that we've got, the less equipment that we have to kind of look after in the long term, and obviously replace as well. You're essentially, you're using pumps that are serviced and maintained by the water companies, water authorities, rather than your own company. So yeah, you're saving money and time and effort that regard as well. And the town main, of course, effectively has an unlimited capacity as well. So we know we're looking for normally 60 minutes of supply for an ordinary hazard group system. So the tank is sort of sized appropriately, have that capacity. So a town main effectively can run and run and run. So yeah, there are a lot of benefits from having a town main supply, but as you probably know already, town main isn't used a great deal for sprinkler systems. A pump and tank solution is by far more common. So maybe you're thinking why that is. We'll be coming on to that shortly. So what is a town main supply? In a previous Sprinkler Talk episode, I did talk about water supplies in general. So a town main supply is essentially just using straight from the town main pressure. So just like turning on a tap, that pressure from the town main is there all the time. We need to go through some non-return valves to make sure that we're not contaminating the town main supply. So sprinkler water is dirty water. The town main supply is clean water, so we don't want those two to kind of mix together. And then, but yeah, once we've gone through a non-return valve, we can go into an alarm valve, and then from then on, it is very much the same as you would get in any other sprinkler system. To section 9 of BSDN 12845, that talks about water supplies, and it defines a town main supply as a single supply. So again, in the previous sprinkler talk presentation, I talked about different grades of supply. So we have single, superior, and duplicate are the three main ones in BSDN 12845. And in TB204, it has a slightly different system for grading the water supplies, and a town main is there as a grade 3 system. So in both cases, the town main is at the bottom of the pile as far as what is best in inverted commas and which is worst. But they are suitable, fully compliant water supplies for automatic fire sprinkler system. In both cases, the town main has to meet the following criteria. So we need sufficient pressure. Okay, so again, this is kind of going back to basics in terms of a sprinkler system. Each sprinkler head has a minimum operating pressure, and therefore we need sufficient pressure from our water supply, either from a town main or from the fire pump, which is going to make sure that when the heads operate, that each head within our area of operation is going to have sufficient pressure to discharge the water effectively. Needs to have a sufficient flow. That's often governed by the size of the pipe. So a domestic supply may only be a 25 millimeter pipe. So that isn't going to have sufficient flow in order to allow in a commercial sprinkler system to allow for all of the heads in the area of operation to operate at once. That requires a fairly significant flow. So we need a larger sized pipe in order to achieve that. Have sufficient duration. Again, seems like a little bit of a. I know that they've kind of got to put that in the written standards, but yeah, as far as I'm concerned, the town main has infinite duration, or at least it's well beyond the kind of 30, 60, or 90 minutes that we're looking for. There's a note to talk about a pressure switch to be installed to detect low supply pressure. Okay, so if pressure drops below a predetermined amount, then we get a warning. I guess it's a case of what do we then do with that warning? Well, there isn't a great deal that we can do, I suppose, other than note the fact that alarm has come in, and if it comes in and stays in, or it appears, every week, for several months, then we've got a serious problem, and we need to contact the water authorities to kind of see what can be done about it, or maybe we need to decide that the town main is no longer of sufficient pressure to be sort of deemed appropriate for the system. There's also a note there to include water strainers where necessary. So, provided we can meet that, then a town main supply, is a good supply to use. Right, moving on now to talk about the town main test. So, pressure and flow are the two things that we want to sort of concentrate on the most. So, how do we do that? How do we know that the town main is or is not suitable for a particular sprinkler system? Well, we perform a town main test. Again, I've got a couple of quotes here from BSDN 12845. So 4.4.4.3, about town mains, where it's talking about basically doing some testing, making a graph showing the availability at peak demand. It doesn't kind of tell you how to determine peak demand, but I think what's fairly typical is that you would take tests that repeat the test several times during a day. So do one in the morning, one in the afternoon, one at night, and then repeat that on several days, and you can kind of figure out yourself. Take basically the worst case scenario from any of those tests. You're looking at pressure and flow that is taken from the town main. Again, very much like you would do with a calculation for a fire pump. You then correct for frictional losses and static head, i.e., okay, that's what we've got at the town main at this point. So is that going to be sufficient by the time we get to the end of our sprinkler system? And then we can make a decision as to whether or not that is appropriate. Again, very much like a fire pump. When we're sizing a fire pump, we want it to cover the certain pressure and flow points on our graph. Well, does the town main do that or not? Then we can make that decision. There's also in 10.7.4 is talking about a slightly different test where you have a boosted town main supply. I'm going to talk about boosted town main supply a little bit more later on in the presentation. But here it's talking about a very similar test, but we're saying, okay, we need maximum demand flow plus 20%. Okay, so we want additional flow. And the pressure, basically we just need half a bar. As long as we've got half a bar of pressure on the town main, then we're happy. Of course, a boosted town main, we're actually fixing the pressure problem via a pump rather than from the town main. Again, noted to be carried out at maximum demand on the main. Okay, so there's a couple of town main tests. Now, these tests would either be carried out by the sprinkler contractor or by the water authority themselves. Again, that's a kind of a conversation. And for me, communication is key. You're not supposed to just kind of rock up and start doing tests. Communication is key in terms of talking to your local water authority, explaining what you want to do, and they might say, "Yep, that's fine, go ahead and do it," or they might say, "No, we're going to do that ourselves," and you can absolutely book in a slot to do that. And there might be a cost, there might not. Okay, so back to kind of pressure and flow requirements. Now, this is Table 6 from BSEN 12845, which is talking about pressure and flow requirements for pre-calculated light hazard and ordinary hazard systems. So your automatic fire sprinkler system might be pre-calculated. It might be fully hydraulically calculated. Again, I've talked about that in the past. I think that the point I want to make is that this table here is for pre-calculated. If you've got fully hydraulically calculated, then the figures are going to be similar. They're going to be in the same ballpark. So this is a useful table in terms of giving you an idea of what town main criteria you're looking for when you do your testing. So this is showing you a flow at a pressure. So we've got 2 points basically to look at, a sort of a nominal flow and a maximum flow, and both have got a pressure associated with them. So let's look at ordinary hazard group 3, wet. So we're looking for a nominal flow of 1100 litres per minute, and we want to achieve that at 1.7 bar plus PS. Now, PS stands for pressure static. Okay, so that is basically the height of the building. We need to allow for the water to travel up the pipe to the heads on the top floor. So we need to add that on to our pressure requirements. Okay, so the taller the building, the more pressure we need from our town main in order for it to still be sufficient. Makes sense? The higher the building, the more that water needs to travel up the pipe. As it goes up, it loses pressure due to gravitational effects. So it is 0.0098 pressure loss per meter. So in basic terms, 10 meters is 1 bar. So yeah, every 10 meters you go up, you need basically an extra bar of pressure on the town main. And then we have our maximum demand flow, 1350 litres a minute at 1.4 plus the static pressure. So again, we've got 2 points here on our curve that our town main needs to achieve. And as I say, if we are looking at the boosted statement, then we need to add 20% to the flow characteristics. So this table here is a good kind of starting point in terms of is our town main sufficient? We can do a test, compare it to these figures, give that tick that box. The town main supplies are only suitable where A, a more robust water supply is not required due to insurance requirements or life safety. Again, in previous presentations, I've talked specifically about life safety. Remember where we need at least a superior twin water supply. Okay, so a town main doesn't meet that requirement. And in an insurance thing, they might say, yeah, we need a grade 1 water supply. We might need a grade 2 water supply. As I've already mentioned, the town main is not going to is only grade 3 and therefore wouldn't sort of meet that criteria. So there are going to be instances where, say, due to other factors, they're looking for a more robust water supply, looking for a superior supply, a duplicate supply, superior twin, something else other than the town main. Town main is only suitable where there is sufficient flow, as we've already mentioned, and where there is sufficient pressure available on the day of the test. Okay, so we need to kind of prove that there is that pressure available. And then also we need that pressure to be available in the long term. Now that is quite tricky. Now that's causes quite a few headaches really, because I think water authorities think, well, why should they give themselves a headache by guaranteeing a particular pressure, because they only need to guarantee the minimum pressure. So instead of kind of issuing a piece of paper which says, yeah, we're going to guarantee 6 bar, say, I think, well, why should we do that? Because we only need to guarantee 1 bar, for example. So getting a kind of a guarantee of the pressure that you experience at the time of the test going long term, it can be tricky. And that, of course, is a problem because you want a sprinkler system that's going to last hopefully for the lifetime of the building. What you may end up with is a situation where you've just finished commissioning and handover, brilliant, and then the next week town main pressure drops. Now the whole water supply is compromised for our sprinkler system. So as I say, I don't really have any kind of solutions to that, but that is a problem in terms of getting that guarantee of long-term pressure availability on the town main. Okay, let's talk about engineered solutions. Okay, so engineered solutions, this is my definition, is designed specifically for the project rather than using a design which is fully covered by the code standards. So the code standards say give you a generic solution, say right, that will do the job, but we can actually produce something that is specifically designed for the project. It's a bit like getting sort of a tailored suit, if you like. It's going to fit. It's going to fit better. In the example of a tailored suit, then obviously that costs more. It always costs more to have something made to measure rather than something off the peg. But that isn't always the case in other areas. So fire engineering, again, I don't want to speak too much for fire engineers because I'm not one, but it seems to me, that's what they're doing on a day-to-day basis. They are coming up with engineered solutions for the fire engineering of a building. They are looking at, okay, what can we do to make this work? And they can prove that it works, which means that savings can be made. You can demonstrate that this equipment here is going to provide suitable fire protection within a particular building, which means that the cost savings can be factored in. Okay, so we can prove, okay, we don't need this equipment, we don't need to have equipment on this scale, we can make it smaller and it'll still do the job. So as I say, the example of our kind of tailored suit is kind of all positive apart from the price, but when it comes to fire, it might be a bit of both. So you might actually get a solution which is cheaper. BSEN 12845 doesn't mention engineered solutions much, and I suppose why would it? Because it's the code standard, so it's expecting you to follow it letter. But it does mention it a couple of times, and here's one example. In Annex E.1, it says special engineering solutions are needed for high-rise systems with hazards greater than OH3. So there it is quite clearly saying, okay, this standard does not specifically cover high-rise systems with hazards greater than OH3. Okay, so if you've got high hazard and high rise, BSEN 12845 is saying, look, we don't cover that, but you're not saying that you can't do it, but you would need a special engineering solution to cover that. So that's an example of an engineered solution. Just wanted to touch on what kind of isn't an engineered solution, which is boosted town main and reduced capacity tanks. So a boosted town main is referenced in the standards. For example, section 9.6 makes reference to a town main with one or more booster pumps as another example of a single water supply. Now, seems to me, and again, I've been told that kind of historically, the idea was that you put a booster pump directly on the town main. So the town main kind of comes in, I guess through a non-return valve, into the pump and then out the other side. So we're literally boosting the town main, dragging it through our pump and increasing the pressure that way. Well, I've also been told, not surprisingly, that water authorities do not permit this kind of a solution, because you're kind of pulling the water out, which is going to mess up their kind of grid system in terms of how the water is fed into other buildings, other areas. So, although it is in the standard, basically no go. Reduced capacity tanks, yeah, okay, so that is partly a solution, and I talk more about reduced capacity tanks in episode 17. It seems to me that reduced capacity tanks aren't all that useful. It seems to me that you can only reduce the capacity a certain amount, a fairly small amount, unless you've got a whopping infill rate that's going to kind of help to reduce it even further. So, reduced capacity tanks aren't very much a solution when you're trying to save space. So introducing pressure check then. So this is our product that we sell as Project Fire. It's one of our first products that we produced, and it's gone through various changes and modernisation over the years. But yeah, it's still essentially the same kind of product that we sold way back in late 90s. So it is an engineered solution for boosting town main pressure for automatic fire sprinkler systems. Okay, so it is a boosted town main. Okay, so we're kind of using that idea of using the town main but boosting the pressure. But importantly, we are doing it in a way which is acceptable by the water authorities, because we're not boosting the water directly from the town main, as I'll explain as we go along. So this is a space-saving solution. So it's about 3.4 meters by 2.3 meters by 2.3 meters. Okay, so it's it's a fairly compact unit. Ease of delivery and installation. Okay, so this you can see it's all prefabricated, and it's designed to split apart. You can see these blue frames here. These are bolted together. So if you've got plenty of space on your site, then you can have a pressure check delivered in one big lump off the back of a lorry, plonk it down, there you are. Or you can have it in individual frames, and that means that it can be installed where access is tight. We can put it into basements, for example, and we can move it around a lot more easily than a larger solution. It's factory assembled, it's all pre-wired, it's all pre-tested. Again, all the benefits that we kind of used to hearing about as far as modular construction and off-site fabrication. That all applies here to our pressure check unit as well. Simplified project planning, again, because of kind of reducing the amount of deliveries. And it's a fast installation as well. So because it is the way it is, a couple of days you can have your water supply completely sorted for a sprinkler system. And we're using, say, approved components where applicable. We've got an approved fire pump. We're using approved isolation valves. We're using a fully compliant controller and initiation board. And the RPZ, the non-return valve, is RAS approved, and we're using RAS approved isolation valves on the side where the town main is located. So yeah, really, it's just a case of saying that if you want to find out more about that product, projectfireproducts.co.uk/products/pressure check. They'll just go to our website, and I'm sure you will find it from there. Here's a few other pictures. But what I really wanted to show you was our Solidworks model. So if I drag that onto the screen, hopefully you can see that. I don't actually have any way of knowing whether you can successfully see that image, but I hope you can. So there we have our full pressure check unit in our 3D modeling package of choice, which is called Solidworks. We're quite proud of this model. It's by far the biggest and most complicated model that we have. So you can see all of the files there on the left-hand side, all the different components. So I haven't actually bothered to go through and count how many there are, but got to be several thousand within this assembly. So let me give you a bit of a tour. So over here we have the connection. The town main connection comes into this T here. That can be swiveled round, which way is more convenient. Town main is going to come into here. It's going to enter this T here, and it's got two options as to where it goes. Let's concentrate on this side to start with. So it's going to flow into this big blue unit here, which is called an RPZ, which stands for reduced pressure zone. It's like a super non-return valve. So again, RAS approved components using the very best equipment for protecting town main. So that's going to go through this valve here, round the corner, and you can see that the pipework now switches to red rather than to blue or to galv, because now we're in basically sprinkler protection land. That's going to come around here, through here, and then out this side. Okay, so pressure check is good for running directly off the town main. That means it's like a hybrid solution. It is an enhancement to the town main, which means that where possible, it will just use the town main. Obviously, the fire pump it's an approved fire pump, very reliable. But if the fire pump were to break or require some servicing, then we do still have the option of a direct town main supply and feed. However, when the pressure is not sufficient, so when we have a sprinkler head activation, that will obviously cause a drop in pressure. That drop in pressure is picked up by our pump initiation board, which is again very similar to what you would see in a normal pump house. So that drop in pressure would then call for the fire pump to start up. So our fire pump will start, and that will then suck water out of this. You can call it a tank if you like, but we call it an RPZ. No, we don't. We call it an AVC. Got my acronyms mixed up there. We call it an AVC, an anti-vacuum chamber. Because this tank isn't really there as a stored water supply. It's there to protect the fire pump and like a brake tank, if you like, from the town main. So that will start sucking water out of the bottom of the ABC, up through here, and then along and out through this elbow into the sprinkler system. They just like a normal kind of pump and tank solution, other than the fact that the pump is drawing from this much smaller tank, so we call an ABC. Now, this tank is going to empty pretty quickly, of course. However, it is getting refilled from the town main. So the town main is coming through here. It's now not going through the ABC because water takes the path of least resistance. As the water level in our tank goes down, the float valves that you can see here, let me just hide the lid so you can see inside. So these float valves are going to drop. That's going to mean that water is going to start to fill up the ABC to refill the ABC. So can you see, hopefully, that as long as the flow is sufficient, as long as we're getting sufficient flow into this ABC, then our fire pump will be able to deliver the pressure required for the duration for an ordinary hazard system. Dave B saying, yeah, this compact system looks good for retrofitting. Yeah, certainly is. It can be used for new build as well. But yeah, it was designed for retrofit applications. It was designed to fix a problem where you have an existing sprinkler system where the town main pressure has dropped. So what we're going to do about it, well, we can install a pressure check. So we've got limited space because the building's already been made. So we can break this down into different components. You can see we've even got the bolts and the nuts model on this 3D model. So each of these frames can be separated out, and they're designed to go through a standard doorway to allow easy assembly on the other side. Juliet says, is the ABC comparable to a priming tank for suction lift? I'm not sure. I mean, they are doing different jobs. So yeah, the priming tank is also a much smaller tank, which is designed to give the pump like a head start in terms of water available to kind of get it going, and then it's going to draw from the main tank. So this one here, as you can see, is under well, I forgot what it is now, but yeah, the centre line of the water is above the pump, so it's going to be self-priming. So no, I think I'll go for no. It's similar in the fact that it is a smaller tank that is not designed for water storage, but it is doing a completely different job. Yeah, but do send in any other questions that you have into the chat. What about some other things to point out? So yeah, these isolation valves here, they are RAS approved. They are obviously coming in contact with the town main. They're all monitored, of course. And then we have our control panel here, which is, again, very kind of typical control panel, which got all the electrics inside of it. And that's got the fault lights here. This has also got relay outputs, so you can wire this to other systems and panels to give fault and fire signals. We've got high and low levels into our tank as well. Yeah, question again from Dave B about putting meters on sprinkled water. Yeah, but this is an argument which has been going for a fair while. It is generally accepted, it seems to me, that sprinkler water should be free of charge. In fact, I did see a letter that was put forward by Lord somebody to kind of make that point, that water for fire protection purposes should be free of charge. However, for me, that there's kind of grey area there as far as testing is concerned. You know, should the water you're using for testing be free of charge? Don't know. And also, I think water authorities don't like this idea I think they get a bit suspicious. I think they feel that, okay, we've given you an unmetered connection. Well, what's to stop you then taking additional feeds and teas off it, and then effectively you've got free water. So yeah, I appreciate your question there in terms of Yorkshire Water fitting a meter, even though it's for a sprinkler system. But yeah, it's difficult. I mean, if that water is also being used for domestic purposes, then I guess they've got a right to meter it. But yeah, I'd say I don't have any particular solutions to that issue. But yeah, I acknowledge that is a problem. That is, an argument that is quite common as far as should there be a meter or not. I mean, I think my concern about meters is that they often restrict the pressure and flow. So on your town main, it's now become a whole lot worse because you kind of got a lot of frictional losses through the meter. Not all meters work that way, but the majority of them do. Yeah, that's right. Yeah, so yeah, Data's saying that the water authority were accusing them of using the water for other purposes, like watering the garden. So yeah, I mean, I've no idea whether that's true or not, but yeah, obviously that they are protecting their business, but by doing that, yes, some compromise needs to come to maybe prove that the water is only being used for fire protection purposes. Okay, so I'll leave it that way. So yeah, thanks so much for tuning in. Next week we're going to be looking at pipe jointing methods. So we're looking at how to join two bits of pipe together, essentially. That will depend on the size of the pipe, the material of the pipe, and obviously there are some options. There's some new technologies, some older technologies in terms of how you do that. So I'll be going through those and showing you how they all work. So yeah, please join me again next week at 10 o'clock for another sprinkler talk. And yeah, just a reminder, I forget what the date is now. It's early, is it? I think it's 2 weeks' time. 2 weeks' time on the 4th of February. I was doing a Q&A session. So please do send in your questions. sprinklertalk@projectfire.co.uk. Answer any questions that you've got, hopefully, fingers crossed. So yeah, do let me know what your questions are. All right, thanks a lot, and I'll see you again next week.